The present paper raises the question of what is random and what is designed. An early input came from William Paley already in 1802, who argued that you could conclude that a watch is designed by studying the connections between its parts. Another related piece came from Pareto at the end of the 19th century. He showed that the distribution of wealth among people is very unfair and broad. This was believed to be caused by human economic transactions and greed. The figure shows the distribution of wealth among the richest person in the United States year 2011. Bill Gates is the richest, corresponding to the data point here. The K is the wealth in $1 billion and the plot is in log, so that a straight line in this plot corresponds to a power law. However, we soon realized that this type of unfair distribution are quite common. The distribution of population shows the same behavior. Here illustrated by the distribution of population of the counties in the United States. Los Angeles is the largest county. Only this time, it seemed more natural to seek the explanation in terms of population growth, commerce and migration. But it did not stop here. It was soon found that the distribution of species among genera had the same distribution. Illustrated by the mammal genera, where the white-toothed shrew has the largest number of species. However, also the distribution of words produced by an author showed the same distribution, which was supposed to have something to do with the structure and development of language. But also distribution of surnames in a country showed the same distribution, which would rather be related to some sociology. Finally, the degree distribution of the chemical reaction network of the metabolism in an organism shows the same type of broad distribution. The figure shows the degree distribution of the chemical reaction network of the metabolism of humans. Water is the most common element. Here one suspects that this should reflect some aspect of the evolution of life. In the present paper, we focus on the chemical reaction network for metabolism and compare it to the inanimate chemical reaction networks of the planet and moons. We show that the degree distribution for both these types of networks in fact belongs to a class of randomly assembled networks, here called the IKEA network after the Swedish furniture store. This means that the shape of the degree distribution is neutral and does not depend on any system-specific aspect. Nor is the shape always power law-like. The moon Titan is also very well described by the IKEA network, although it is definitely not power law-like. The degree distribution for the moon Titan is shown here, and it's definitely the data is not in a straight line, though it is extremely well described by the IKEA network. The upshot is that all these systems are described by the same neutral non-systems dependent theory, as is illustrated in this figure, where the curves are the predictions from the neutral theory in the form of a random group distribution. And it predicts all these cases, the distribution of richness, the population distribution, the distribution of genera and species, the distribution of words, the distribution of family names, and the degree distribution of the metabolism. Thus, degree distribution of various shapes, even power law shapes, are often just a reflection of a random assembling and is a very non-system specific feature.